But anyway, as long as I telling you that there is a change of classrooms, it's still the same. I mean, we still have classes in the same classrooms. It would be good that someone tells me, okay, you have to teach this Monday in another classroom. Okay. First, attendance. Guys, I'm checking attendance. If I don't hear yes, you are absent, okay? Okay. Sarah? Yes. Donia? Yes. Margot? Yes. Anna? Yes. Ernest? Yes. Leonie? Yes. Anisha? Yes. Yutan?
Yes.
Thank you. Yes. What? Perdón. Sí. Es que tengo la hora reservada para un examen. Ya, pero es que, o sea, hasta no me han dicho nada. Entonces, no me han dicho nada. Y yo, aquí tenemos clase como siempre. Y no, es que de verdad que mi aula está todo. Pero es que no tengo este aula de planificación confirmada y no un examen a las 3. Voy a ver si hubiera cambiado de la
No,
I mean, study.
Yeah.
Yeah, anatomy and biochemistry.
Yeah. Just like 13 minutes.
What?
13 minutes, I believe.
No, we stay.
It's okay if there's anything we repeat for you.
We are going to do the reinforcement activity now. Yes. Because I need to. Okay. You're so. Okay. Well, first, is everyone agree with doing the reinforcement activity now, or do you prefer to do it at the end? It's just because.
No.
Now?
No.
Sure? Okay, perfect, guys. So, I'm going to finish checking the attendance. So, Lion? Rasim? Yes. Amy? Aaron? Yona? Alessandro? Marie? Yes. Alexander?
Yes.
Maria? Yes. Chris? Diana? Yes. Alia? Sara? Shaista? Kimi? Victoria? Isabela? Lorenzo? Erica? Zach? Hiba? Fanny? Kelsey? Arthur? Sean? Luke? Ryan? Yes. Melanie, yes. Rita? Yes. Fine. Yes. No, you don't appear in the list. I don't know why. It's the same case as in the practical activity. Yeah. It's because I've seen you, right? I don't know yourself. But anyway, I have your activity. I know that you have come. Don't worry, okay? So, I need you to be as separated as possible to do the reinforcement activity, okay? I don't want you to separated. Kimi, sit down in between. Yes. Yes. So I must trust you because you are very close. Okay. What are they? I don't think so. But whatever I'm saying, probably it will be the other way around. I think it is. I think it's. Okay. Please, I need you to be quiet from now, okay? Thank you. I don't want to see any mobile phone on the table, nor tablets, iPads, whatever.
Thanks.
Elle m'a pas envoyé hier. Non, c'est pas ça. J'ai même pas eu la moitié. Ça y est, t'as eu le même pied. T'as eu le même pied. Ouais, les 4 sujets. J'ai même pas eu la moitié. Alors, ça fait ça, on a la moitié. J'ai même pas eu la moitié. Moi, j'ai pas 5. On avait combien 7. On avait 14. Non, non, je suis venu.
I was not sure because I thought about writing about layer matrix, but it's containing 10 hair matrices then. But there's no level sizes, so I think
I didn't get one. The website did say.
also about your
It was on earmarks.
Okay, guys, let's start with our class, okay? Because we have lost our time. So, if I'm correct, we finished the first slides of the first presentation of Unit 5, and I don't remember very well if we started explaining the components of blocks. Do you remember?
We did.
You don't.
Yeah.
Yes, we started or not?
Yeah, we did.
No? Perfect. So, as I have more than 2 groups, it's sometimes difficult for me to remember. So, are you sure that I didn't explain this?
Yeah, we did.
We did. We did too. And this. And this. Sure.
No, we did not. I think we stopped at 5.4. Yeah, no.
Hématocrit? Oui. Non, we don't.
Yeah.
No.
See, I hematocrit, I think.
We explained hematocrit and we stopped right here.
Because the last thing I.
Yes, that's what I remember, but I wasn't sure. Okay, so we start here. Okay?
What is hematocrit?
This
Yes. Hematocrit.
hematocrit is the percentage of red blood cells that we can find within a sample of blood. So if the value is 45%, then that means that that's the portion occupied by red blood cells in that blood sample. That's it. Well done. So, okay guys. Well, in the meanwhile, as the rest of the people take a long rest, on Thursday we have the next reinforcement activity, yes, about Unit 4, yes. So this reinforcement activity will be a test, and it will contain very similar questions to the midterm ones. So it doesn't have negative marking though. So apart from having this test, this MCQ questions in this reinforcement activity on Thursday, you will have one written question that will integrate content of Unit 2, tissues, and Unit 3. I guess that Unit 3 is fresh, so you won't have many problems because you will have to write everything that you know. So it's like an open question, right? The rest of them are test questions, and I think they are easy. Some of them will have an image, so you will have to distinguish structures in those images, but the rest I think are easy. Okay? So that's the next reinforcement activity this Thursday, right? This one about the skin, did you find it difficult, meh, or easy?
Which one?
This one.
No,
Easy, medium,
Medium.
Okay. Yes. I think, as I have seen, as I have been reading while I was collecting them, the results are good. So don't worry. You are not going to fail, or I think it will be difficult. You do, Zach? You are going to fail?
No, I didn't say anything.
Okay. Yes, Alia.
So we'll be able to get the reinforcement activities back corrected.
If you ask for them, you will. But if you are not interested, you just have your rest.
How do we come? Where do we go to get our other one back then? If we can ask them, like the previous one we did.
Do we ask you or do we? So the ones that are interested in seeing the corrections of the previous reinforcement activities, you have to ask me, and then in the next class we see it after the lesson. Yeah?
But we can only see it and not take it back?
No. You can take them back because there are sometimes groups that haven't done them yet. So
we can take a photo either?
But no, it's what
Nothing.
that we made the test.
what?
All the groups have already made the test. So the first one,
The reinforcement activities are exactly the same for all the groups. The difference is that depending on how quick or slow each teacher is, they will do it earlier or not, as we do. So we want to avoid that. If you do it earlier, you will tell your partners how tired they are.
C'est grâce à moi que vous avez quitté les cours.
We can give you back. You can see the corrections, but you can't have them.
Pas du tout, mais
Okay, so more questions? No? Fine. Yes or no? Fine. So let's start hematopoiesis. Okay? Let's see if we can finish this presentation today. So, what is hematopoiesis? Guys, please. Guys, please. So, what is hematopoiesis? It is a process by which all the foreign elements in the blood will be replaced or synthesized again. Because depending on which cells we have in the blood, they will have a mean life which could be shorter or longer. So, depending on the stage of life, is this process of hematopoiesis will take place in different organs or tissues or whatever that we have. During the first weeks of life, as the embryo is suffering these changes, the hematopoiesis will take place in the yolk cell as the embryo is being generated. Second, guys, if you want to go outside, take a break, or go home, for me it's okay. But please, I need you to be quiet because this is the last hour for everyone. I am tired. It's hot. You have been doing other things, other classes. I know you are tired too, but please. That's the only thing I ask you while we are in class. Thank you. So, as I was saying, in the second trimester of pregnancy, this process of hematopoiesis takes place in specific organs that are very important, such as the liver, the spleen, the thymus, and the lymphatic nodes, among others. But after the birth, during or before birth, these last 3 months, the last trimester before the birth and during the adult life, we know that hematopoiesis will take place in the red bone marrow. Okay? So, which are the main characteristics of the red bone marrow, of this tissue that can be found mainly in the spongy bone? Okay? So, it will be very vascularized. Why? Because we are going to see a very high demand in this red bone marrow as all these 4 elements need to be synthesized. So, this highly vascularized connective tissue will be located in the trabeculae of spongy bone tissue, but we can see this red bone marrow in specific bones. For example, the ones in the axial skeleton. Others, for example, the pectoral and pelvic girdles, and important in the epiphyses of low bones inside these epiphyses, such as the humerus and the femur. Right, so what is important about the red bone marrow apart from being highly vascularized? We need progenitor cells, which are stem cells, which are pluripotent. From these stem cells, we are going to see a differentiation as they are going to divide and finally get the mature form of these 4 elements. So, an important thing about the hematopoiesis is that once we have all these 4 elements synthesized already, when they go outside to the bloodstream, they stop dividing. But we have an exception, which are lymphocytes. And why do we have this exception? Because the lymphocytes, as they are one of the most important cells in the immune system, when there is an infection and inflammation, they will have to divide to detect the antigens and the strange microorganisms so that this immune response is quicker or very quick, and it will last as short as possible. Okay, so as I was saying, we need a stem cell, pluripotent ones. We will need progenitor hematopoietic cells, so that from one pluripotent stem cell, we're going to have 2 lineages. The myeloid one and the lymphoid one. So, as we have these 2 lineages, from one pluripotent stem cell, as it is going to be differentiated, we can have a myeloid stem cell, which is the precursor of all these cells that you have here, which are red blood cells, platelets, mast cells, and granulocytes. But also monocytes, which are like the immature cells that will give rise to macrophages as they arrive to the tissues when we have an inflammation or an invasion of strange pathogens. On the other hand, we have the lymphoid lineage, by which a lymphoid stem cell can give rise to lymphocytes, specifically T lymphocytes, B lymphocytes, and natural killer cells. We will see later the characteristics of each one of these cells. So, maybe you are asking what is like the key element so that we can have one cell or another. We will talk about that too, don't worry. Which is about this. Okay, so to regulate the process of hematopoiesis, if the organism needs, yes, Alessandro.
I have a general question about the reinforcement activity for this unit. We're going to do it next week? Or
I'll tell you, okay? Probably next week. But on Thursday I will tell you because probably it will be on next Thursday, but I don't know, okay?
we have a digital blog also for this unit or not?
Yes, this Friday. Okay, these questions at the end, okay? For the next time. So, the key factor or element so that we can have one cell or another during this hematopoiesis or this synthesis of foreign elements in the blood are growth factors. So these growth factors are proteins that are in charge of regulating the proliferation, differentiation of these precursors so that we can have a particular type of foreign element or another. So as you can see from a 1 pluripotent hematopoietic stem cell, we have these two precursors, right? The lymphoid stem cell and the myeloid one. So depending on the lineage, we're going to have different growth factors that are all proteins, and most of them are synthesized in the liver, and we can have also hormones, as in the case of erythropoietin or EPO, and also TPO or thrombopoietin. We will talk about TPO, we're talking about platelets in the second presentation of this unit, okay? So, what about what you can see in this slide? These colony stimulating factors, what are those? These guys are glycoproteins that are in charge of differentiating one particular precursor cell or progenitor cell into the mature cell. So, in the case, for example, of having this colony stimulating factor as this one or just this one, if you see these letters, in this case mean granulocyte, monocyte, colony stimulating factor, or just monocyte, colony stimulating factor. So, depending on which ones do we have, probably this myeloid stem cell will differentiate into the precursor of one granulocyte or one monocyte.
Miss, what does the G stand for? The G.
G granulocytes, M monocyte, always, okay? And CSF, colony stimulating factor.
What's important for us to know about this one?
What I'm telling you, I just want you to understand this slide, but the important thing about this is the concept. What are these growth factors? They are proteins in charge of regulating the process of hematopoiesis. We can find special proteins like the colony stimulating factors, which are glycoproteins, or we can have hormones, as in the case of EPO and also TPO. But we will talk now about EPO, so don't worry.
So it's either these two proteins or it's a hormone that stimulates the...
Both. It depends on the different cell type. EPO will give rise to erythrocytes from one myeloid stem cell. In the case of TPO, we will have this progenitor cell, which is the myeloid stem cell, that will give rise to a megakaryocyte which is the precursor cell of the platelets, which is very, very big and stays in the red bone marrow. And after, this myocardicyte will be fragmented. And all those fragments are platelets. We will talk about it, don't worry. Yes? Okay, so why are all these growth factors important? Because if we have any pathologies, disease such as cancer, or we need any transplants of stem cells, they will help us to have this process of hematopoiesis to be regulated. For example, if the levels of red blood vessels are very, very low, as we have the case of chemo during cancer, this treatment will affect a lot the hematopoiesis process. So sometimes we need these pathologies to be treated by the transplant of stem cells. Okay? Just that. Okay, so now we are going to explain all the characteristics of every form element that we have mentioned already, starting by the red blood cells. Aaron, what happens?
It's my bag.
Can you? So, characteristics of red blood cells. As you might know already, they have a very particular morphology because they are very, very flat cells, and they will lack from something very important for cells. Do you know what it is? Nucleus. But apart from lacking from nucleus, they lack from other organelles. For example, mitochondria, ribosomes, and endoplasmatic reticulum. Do you remember why are these endoplasmatic reticulum and ribosomes important for? Protein synthesis, exactly. Protein synthesis. So, what happens then if a cell doesn't have nucleus, nor ribosomes, or endoplasmatic reticulum?
It cannot synthesize protein.
Yes, and then they will, as long as they live, if they suffer from any damage, they couldn't repair any structures of its membranes or the cytoskeleton or cytoplasm, nothing. So they will have a specific mean life. After that, they will die and be removed from the bloodstream. Okay? So, another important characteristic of red blood cells is that they contain a very important protein, which is hemoglobin, in charge of transporting oxygen and also CO2 back to the heart. Okay? Important. As they don't have mitochondria, they will obtain energy through anaerobic glycolysis. Okay? And also they will have a very important enzyme that we have mentioned earlier, which is the carbonic enzyme, anhydrase, sorry. The carbonic anhydrase. We will see why this is important now. Okay? So, guys, why do you think these red blood cells or erythrocytes have this particular morphology? They are biconcave, they are very flat. Why? Why are they so different compared to other cells?
So they can
Carry more oxygen.
Raise your hand. Stop.
to fit in small capillaries.
More.
They can carry a lot of oxygen.
Okay?
No, it's the same thing.
They can diffuse. Very good. Both. The important thing about red blood cells and its morphology is that as they have this particular structure of the cytoskeleton that at the end will give them this particular morphology, they will be able to pass through the capillaries so that they can diffuse from these capillaries to the interstitial fluid to the tissues. So, due to that, they will be able to transport oxygen from the bloodstream to the tissues. Okay? Fine. So, now we know that one important function of these erythrocytes is the transport of oxygen, but also I've told you that the transfer of CO2 is important. But be careful, because erythrocytes don't transport CO2 from the heart to the tissues, because CO2 is a gas. Yes, a gas that is produced during the metabolism of the cells. So once these cells receive oxygen and nutrients, they will expel CO2 and waste products back to the bloodstream. And then CO2 will be transported to this bloodstream. Just one little portion of CO2 will be bound to the hemoglobin, but the rest will be transported in the bloodstream differently, as we are going to see. More functions of the erythrocytes. They will be in charge of regulating the arterial pressure and also the blood flow. Be careful here, because ATP normally works as a vasoconstrictor. If you remember when we explained thermoregulation, we saw at the end that we find mainly different molecules depending if they are vasoconstrictor or vasodilator. We said that one important vasodilator is nitric oxide. And talking about thermoregulation, ATP was an important vasoconstrictor. So be careful here, okay? Normally, nitric oxide is a vasodilator agent, so that it will help to expand the blood vessel walls and increase the blood flow. So, yes?
So is it that they release nitric oxide not ATP?
Yes, the endothelium, which is the epithelium that covers the blood vessels, will release nitric oxide in case we need vasodilation. Okay? So, about this gas transport, specifically about oxygen transport, we have talked about hemoglobin, which is a very important structure within these erythrocytes that is made of 4 important proteins known as globins. These globins will be divided into 2 alpha chains and 2 beta chains. And this hemoglobin, this structure, these 4 chains will be bound to an annular structure that refers to a structure that it looks like a ring, which is the M group. What is so special about the M group? Do you know? Have you seen it in biochemistry? Apart from that, what is special about this M group? It's also a protein? No. M group is prosthetic. That means that it is not a protein part of the hemoglobin. Okay? Just for you to know. So then, each hemoglobin, as it is made of 4 globins, each one of them will have this M group, in which we can find in the center a very important ion, which is the iron ion. That's why the blood tastes like yeah? You didn't know this? No? Well, you know now. Okay. That's why. So, this is the structure, guys. This whole structure corresponds to this M group. So, this annular or structure, let's say it looks like a ring, is known as a porphyrin ring. Okay, just for you to know. And I'm not going to talk about chemistry. Anyway, in the middle of the M group, we find this iron ion That is the key element so that oxygen can be bound to the hemoglobin. So that each hemoglobin can transport 4 oxygen molecules. Okay? As each globin will contain 1 M group, 4 M groups, 4 oxygen bound to each one of the iron ions. So, now let's explain what happens to you guys today. You're very talkative. So, we have just talked about how oxygen is transported by hemoglobin. But I just told you too that CO2 will be bound partially to hemoglobin. So, what happens here? So, once this CO2 is released from the tissues, we are going to find part of it just dissolved in plasma. So, imagine that we have 100% here of CO2 that is just in the bloodstream, and it needs to be transported back to the heart. From, well, 7% out of 100% will be just dissolved in plasma as CO2 and nothing else, right? As it has been produced by the tissues. But what happens with the rest of this CO2? We have 2 ways by which CO2 will be transported within the erythrocytes. So, one of these ways is that 23% out of this 93 will be bound to hemoglobin, forming what we know as carbaminohemoglobin complexes. Carbaminohemoglobin complexes. So part of the CO2 is already transported. What happens to this 70% out of this 93? CO2 in here, by the action of this important enzyme known as carbonic anhydrase, will be transformed with water to carbonic acids. And we know that this acid is very unstable and will dissociate into 1 proton and bicarbonate ions. So, this is the reason, guys, CO2 will be very, very important to regulate the blood pH. Because all those protons, as they accumulate, they will make slightly more acid in the bloodstream. If we have less of these protons, then the value of the pH of the bloodstream will tend to be more alkaline. Okay? So, as this chemical reaction takes place, what happens to the protons is that they will be removed by buffers, okay? So that they can regulate this blood pH. But what happens to this bicarbonate ion? It will go directly to the bloodstream, but it needs to go out first from the erythrocytes. So as it is synthesized, we have this co-transport by which bicarbonate ions will go out of the erythrocytes and chloride ions will go into these cells, these erythrocytes. There is an exchange of these ions. So why is this important? Because the main way by which CO2 will be transported in blood is not due to hemoglobin, but because of the action of carbonic anhydrase, because it will transform CO2 and water to bicarbonate ions. Okay? This is important, guys. Understood? Yeah? Okay. So now, let's talk about how these red blood vessels are generated, right? We have see that the hematopoiesis is like the general process by which all these foreign elements are synthesized or replaced. Well, the special process by which erythrocytes are synthesized is the erythropoiesis. Okay? The thing is that in the red bone marrow, we are going to have this progenitor hematopoietic stem cell that will give rise to specific precursors or progenitor cells that will proliferate and differentiate into different stages until we have the mature form of the erythrocytes. So, what is important really about this so that you can understand? Okay, so one of the main precursors of erythrocytes is the proerythroblast. Do you remember when we were talking in Unit 2 about tissues? That we differentiate the immature cells and mature ones depending on the suffix. Blasts are immature cells, so again they appear. Proerythroblast is one of the earliest precursors of red blood cells. So they will differentiate, divide, and they will give rise to the erythroblast. So let's just forget about these two stages because I prefer you to know that we have in general, even though this is true, the erythroblast. Okay, so in here from proerythroblast we will have erythroblast. We can remember this because once we take this prefix, pro, we just have erythroblast. But depending on the stage of development, we will have the early or late erythroblast. Never mind. What is important about this, about the erythroblast? That it will give rise to the last precursor of erythrocytes, which is the reticulocytes. This is important that you remember because once we have these reticulocytes, which is the last immature form until we have these erythrocytes, they still have specific organelles such as ribosomes and endoplasmatic reticulum. But when they are about to leave the red bone marrow, they will lose their nuclei. So, what happens then after they are already in the bloodstream? Approximately 48 hours from this, when the reticulocyte goes from the red bone marrow to the bloodstream, they will start losing the rest of these organelles. When they are already in the red bone marrow, they lack the nucleus. But when they go to the bloodstream, they start losing the rest of the organelles. So that after these 2 days approximately, we will have the definitive form of the erythrocyte that lacks from nucleus, mitochondria, ribosomes, endoplasmatic reticulum, and finally we have the definitive morphology. Okay? So, about these ciphers, these timelines, I don't really care that you know by heart this, but I prefer you to understand the whole process of erythropoiesis. That is, when these precursors still have nucleus or not, why it is important, and so on. Yes?
The first one, hemocytoblast, is it like a myeloid cell?
Yes, it's a stem cell. It's a myeloid stem cell, exactly. Okay? That comes from a pluripotent stem cell. Okay? Fine. So, why do these cells, these erythrocytes, produce in the red bone marrow? Just because? No, we need from several factors and hormones such as the EPO or erythropoietin, as I was talking about before. So, imagine guys that we are in a circumstance by which we have a lack of oxygen. For example, imagine you are in a mountain and you are closer to the peak, okay? So there, the oxygen partial pressure decreases. We have a lack of oxygen. So the organism will notice this and will send several signals, and one of these signals will be the synthesis of this hormone, erythropoietin. This erythropoietin will be synthesized by the kidneys. So once this hormone is already in the bloodstream, it will go directly to the red bone marrow so that this erythropoiesis process can take place and more red blood vessels will be synthesized. Why do we want more red blood vessels? Because if we are having a lack of oxygen, we want more cells that will be able to transport this oxygen that all the cells in the organism need. Okay? So, during this process, we will need from other factors, other nutrients, such as vitamin B12 and also folic acid, another vitamin. Okay? So, as we have a higher number of erythrocytes, the partial pressure of oxygen will increase, and all this oxygen can reach properly the tissues. Okay, so as I told you before, due to this morphology and the lack of all these organelles, the mean life of an erythrocyte will be quite short, about 120 days. Okay, it could be a little bit less, more, but approximately this is the period by which one erythrocyte will be circulated in the bloodstream. But after that, what happens to an erythrocyte? Or, better said, what happens to all these structures? Let's see it. So, when we have a dead or deteriorated, degraded erythrocytes, we need cells that are in charge of removing all these wastes or these debris, right, in the bloodstream, which are macrophages mainly. This cell corresponds to a macrophage. Where do we find macrophages? In the spleen, the liver, or even in the red bone marrow. In the spleen, these macrophages will be very important as this organ works as a filter. So, if we have young red blood cells, they will be able to pass to the spleen or by the spleen. But if they are damaged, due to having an irregular morphology as this one, they will be retained in several organs such as the spleen. So, then, after all, what happens to this cell after a macrophage has done phagocytosis? Well, all its components will be degraded, but we have mentioned that the structure of these erythrocytes, specifically the structure of hemoglobin, is a little bit complex. So, on the one hand, we have the globins. The globins are these proteins that are forming the change, the polypeptidic change, of the structure of the hemoglobin. We have 4 globins, 2 alpha and 2 beta chains. So as they are proteins, they will be degraded into different amino acids, right? So all these amino acids will be reused for protein synthesis in general. It could be for generating new globins when we need from new erythrocytes or any other processes. Okay, what is the second component of hemoglobin that we have talked about? M group. But the M group has, let's say, not different, but a special structure by which one of its components, its main components, is the iron ion. So what happens to this iron ion? It will be reused too? Yes, because once this erythrocyte has been degraded, this iron ion will go directly somewhere else. For example, the liver, the skeletal muscle, and also it can go to the spleen, so that this process of erythropoiesis can take place again. But this iron ion can't go on its own until the liver, the spleen, or the skeletal muscle. It needs from something special, a special transporter protein, which is the transferrin. Transferrin is the protein that will be bound to the iron ion, so that when this ion is stored in these muscles for its later use, then the transferrin go back to the bloodstream in case there is more ion to be transported, and now the iron ion will be bound to another protein, which is ferritin. Okay? So as long as the iron ion it is not needed, it will be bound to this protein, the ferritin. Okay? And finally, what happens to the rest of the heme group structure? As you can see in here, this N group will be degraded and converted to biliverdin. So guys, what happens when you fall down and you have received any stroke? What happens? What does appear in our skin? Hematome or brush, right? Hematomes, yes, a brush. And everyone knows what a brush or hematome is, right? Yes. So as the days pass, our brush or hematome will change the color, right? This is because this blood is being degraded. It passes from purple to green to yellow and so on. So one of these pigments originated from this blood degradation is biliverdin. That will be converted to bilirubin. Bilirubin is a very toxic substance that needs to be eliminated from our body as soon as possible. So when we have bilirubin, it will go directly to the liver as well. Why are we talking all the time about the liver? Because this is one of the most important organs in the body. It is like, let's say, I don't know the exact word right now, but imagine that we have a place in which we have the detoxification of every substance that could be harmful to us, such as drugs, medicines, and other toxic compounds that are produced due to metabolism, right? So that's the liver. So once we have the bilirubin in here, in the liver, what happens to it? Because it needs to be eliminated. So the bilirubin, as the digestion takes place, will pass to the small intestine as the bile, right? It passes to this as bile. So once the bile is already in the small intestine, it will go on its pathway until it reaches the large intestine. Why the large intestine is important? Because in here we have our microbiota or microbiotes, which is like all the microorganisms that live in our gastrointestinal tract. So specifically in the large intestine, we find a lot of bacteria that are in charge of different processes and that they are very helpful for us. So one important function that these bacteria in the large intestine do is to convert bilirubin, that remember is within the bile, into urobilinogen in here. But this urobilinogen will be transformed into two other molecules. One of these two will be excreted by the urine as urobilin. Urobilin is this yellowish substance that will give color to the urine. So this is one of these waste products from bilirubin. What about the other compound that comes from urobilinogen? This is estercobilin. Due to the action of this bacteria, this is the substance that gives this brownish color to the feces. Okay? So one way or another, the bilirubin will be excreted or eliminated by the feces. Okay? Sorry. So then, to have new erythrocytes, what happens? We have said that we have amino acids that could be reused, for example, in the red bone marrow to produce new erythrocytes. We have also the iron ion bound to the ferritin in the liver that could be used again in the red bone marrow as long as it is bound in the bloodstream to the transferrin and goes to this red bone marrow. Sorry. So imagine we have this iron ion, we have the globins after the protein synthesis here and here, and other nutrients, for example, vitamin B12 and special hormone as the erythropoietin, so that we finally could have new erythrocytes. Okay? Questions? No? Perfect. Would you let me finish the presentation? Or are you too tired? Okay, we can leave it here.
Elle va me séparer, j'espère que j'ai envoyé hier. Non, c'est quoi ça? J'ai même pas eu, j'ai même pas eu la moitié. Ouais, et 3, 4 aussi. Ça y est, le même pied. Et le même pied. Ouais, les 4 sujets. J'ai même pas eu la moitié. Ça fait ça, on a la moitié. J'ai même pas eu la moitié. Moi, j'ai pas 5. On avait combien? 7. On avait 14. Non. Non, c'est génial.
I was not sure because I thought about crisis about the matrix, but it contained 10. right answers.
I didn't get one.
Also about your life.
It was on Iraq.
Okay, guys, let's start with our class, okay? Because we have lost our time. So, if I'm correct, we finished the first slides of the first presentation of Unit 5, and I don't remember very well if we started explaining the components of bloods. Do you remember?
We did. I think.
You don't.
Yeah, we did.
Yes, we started or not?
Yeah, we did.
No? Perfect. So, as I have more than 2 groups, it's sometimes difficult for me to remember. So, are you sure that I didn't explain this?
Yeah, we did.
We did. We did too. And this. And this.
No, this one no.
Sure.
No, we did not.
No.
I think we stopped at 5.4. Yeah, no.
Hematocrit? No, we don't.
Yeah.
No.
See, I hematocrit, I think.
We explained hematocrit and we stopped right here.
Because the last thing
Yes, that's what I remember, but I wasn't sure. Okay, so we start here. Okay?
What is hematocrit?
This
Yes. Hematocrit.
hematocrit is the percentage of red blood cells that we can find within a sample of blood. So if the value is 45%, then that means that that's the portion occupied by red blood cells in that blood sample. That's it. Welcome. So, okay guys. Well, in the meanwhile, as the rest of the people take a long rest, on Thursday we have the next reinforcement activity, yes, about Unit 4, yes. So this reinforcement activity will be a test, and it will contain very similar questions to the midterm ones. So it doesn't have negative marking though. So apart from having this test, this MCQ questions in this reinforcement activity on Thursday, you will have one written question that will integrate content of Unit 2, tissues, and Unit 3. I guess that Unit 3 is fresh, so you won't have many problems because you will have to write everything that you know. So it's like an open question, right? The rest of them are test questions, and I think they are easy. Some of them will have an image, so you will have to distinguish structures in those images, but the rest I think are easy. Okay? So that's the next reinforcement activity this Thursday, right? This one about the skin, did you find it difficult, meh, or easy?
Which one?
This one.
No, easy.
Easy, medium,
Medium.
Okay. Yes. I think as I have been reading while I was collecting them, the results are good. So don't worry. You are not going to fail, or I think it will be difficult. You do, Zach? You are going to fail?
No, I didn't say anything.
Okay. Yes, Alia.
So we'll be able to get the reinforcement activities back corrected.
If you ask for them, you will. But if you are not interested, you just have your breast.
How would we come? Where do we go to get our other one back then? If we can ask them, like the previous one we did.
Do we ask you or do we?
So
the ones that are interested in seeing the corrections of the previous reinforcement activities, you have to ask me, and then in the next class, we see it after the lesson. Yeah?
But we can only see it and not take it back?
No. You can take them back. Because there are sometimes groups that haven't done them yet. So
we can take a photo either?
But no, it's what
Nothing.
that we made the test.
what?
All the groups have already made the test. So the first one, the first activity.
The reinforcement activities are exactly the same for all the groups. The difference is that depending on how quick or slow each teacher is, they will do it earlier or not, as we do. So we want to avoid that. If you do it earlier, you will tell your partners how are they.
C'est grâce à moi que vous avez toutes les réponses.
We can give you back. You can see the corrections, but you can't have them.
Pas du tout, mais j'ai
Okay, so more questions? No? Fine. Yes or no? Fine. So, let's start hematopoiesis. Okay? Let's see if we can finish this presentation today. So, what is hematopoiesis? Guys, please. Guys, please. So, what is hematopoiesis? It is a process by which all the foreign elements in the blood will be replaced or synthesized again. Because depending on which cells we have in the blood, they will have a mean life which could be shorter or larger or longer. So, depending on the stage of life, this process of hematopoiesis will take place in different organs or tissues or whatever that we have. During the first weeks of life, as the